Hey, so today we're going to have a look inside an Epson PowerLite Pro 9870U, and that's an XGA projector, so 1024 by 768 at, I think, 8700 lumens. So that's a pretty bright projector. As you can see, it's probably a pretty big one, too. It's around 2.5 feet or something. It's about at like... 1.5 feet, close to 2 feet wide, and it's probably 12 inches. Not necessarily there, but I think we're at a good like 6-7 inches thick or something. It's a massive projector. It's I think 60-70 pounds easily. It didn't come with a lens or lamps, and it's still heavy. So yeah, it's a Z9870U, but it doesn't say that on the front there. Here we got a filter, and the filter door is attached nicely because this is often going to be mounted on a high ceiling where you don't want things to fall down by accident. And the filter looks pretty clean. You got 3 fans in here for the intake, probably going to be blowers. Around the back you got the controls, and back there's a lamp door, and the lamp door actually has the fans on it. It's hinged. It takes 2 lamps, and there's 2 fans, one for each lamp. It's on a pretty hefty hinge. Unit didn't come with a lens or there was no lens or lamps in here, so this is probably going to just be a teardown, and I'm not putting this one back together. Here we have some inputs. There's some Ethernet ports, HDMI, the usual. It's got a C20 power inlet because so when I plug it in, it's pulling 2.5 watts or something. Doesn't do anything when the power button's pressed. And yes, I have tried a lens on it, but I don't have lamps for it, so I'm guessing it just won't work. Of course, I'm not sure if it's just missing the lamps and the lens and it won't power on because of that. I'm not sure what kind of detection it can do with 2 watts. It doesn't seem like the main power supply is starting, but let's have a look inside anyway. I don't have anything to test it with anyway, so. Looks like back cover gets stuck on the hinge a little. Had to close that first. And we're in. It's a pretty complicated machine in there. There's a big main board. It's a pretty heavy case too. Whole thing's like 60-70 pounds. That's a good chunk of it there. You can see what looks like a liquid cooling system up front. There's lots of boards just for interface and whatnot. There's a little board with the power converters on it. Looks like some power supply. Down here it looks like some control panel stuff. A little fan for the lamp. I think there's more interface boards and a bunch of DC-DC converters, probably for the fans or something. But none of them are 4-pin. There's a HD base T transceiver chip, it looks like. So Ethernet's probably for HD base T for display. Got more cooling hoses for the liquid cooling. There's a pump, I think. There's a main processor down there. What's under here? Looks like a heatsink sticker or something, like graphite or something. Looks like a lattice FPGA, probably doing some digital interface or whatnot. Probably nothing video because there's chips for that. Overall, it's a pretty complicated machine in here. There's a high current or high voltage wiring for the lamps down there, the control board. Looks like a lamp ballast here under that control board, and that little interface board. Looks like a lamp ballast for the 2 lamps, and there's a fan for that. And got the air duct, carries the heat from that fan. That's the intake, and it goes all the way back into the lamp housing. And you see the exhaust fans in the back, I guess. Looking at the back here, the fans are on a really hefty hinge, actually. That's actually a really hefty hinge. I wasn't expecting that. On the other ones I have, the fans just pop out. I'm surprised they put them on such a big hinge. There's lamp holders. I mean, those look like just clips that hold the lamps in. The dual lamps are probably how they're getting the 8700 lumen output. It's definitely going to be a lot more input, of course. I think it uses two 380 watt lamps, I think, and they just clip in like that. Here's a picture of the inside so far, in case you wanted it. They've got some interesting fan grills on them. I quite like those, definitely keeping them. Lots of screws. Let's lift the fans out if we can. Just comes apart like that. There's two pieces to this. It's quite a complicated little back cover. They just plug in and got them disconnected. Made by NMB, and they're 12 volts actually, surprisingly. Normally they're like 24 and things like this. They're actually well designed. I like the design of them. They're pretty quiet when they're running. They have the same ones on the other projectors I have that work fine. Actually pretty quiet, high quality ball bearing fans. 3-pin though. Continuing on, here's a metal bracket. It's really heavy. Everything in here is really heavy, and that's a pretty thick gauge steel. It's for bracing or something. Here's a cover, and under here we can see the fans that cool the lamp. So actually the lamp seems to require quite a high pressure or something to cool, to blow it through, I'm guessing, the lamp housings. So they actually got these really small fans, like they've only got 3 of them, and it's for like lamps are like 380 watts each. So the big fans in the back are actually just exhaust fans. They don't actually seem to pull the air through the lamps. I don't have lamps, so I don't know how they're arranged, but just 3 small blowers, probably like 60 millimeters, I'd say. Good quality though. You blow down to the bottom, and in something like this, temperature sensing is always really important. So you can see there's thermistor boards under the fan tray, just to make sure both lamps are operating within specification. You have 2 lamps, probably a mirror arrangement. They're pointing in, it seems, and they shoot straight out in the middle to combine their light output. There's of course a thermistor there, make sure it's not getting too hot. Here's a closer look under that cover. So there's a prism mirror that lights fire through, and then there's this shutter. It opens and closes, probably for dynamic contrast. It's got a little stepper motor on there to limit the light output. I think it's probably for like dynamic contrast or like something like that. You can see it's gotten pretty hot because all that light output right onto those pieces of metal right before the lens. Okay, so let's move on to the front of the machine and take out the electronics. There's a big board and actually another processor under that. So it's got some DRAM on it. There's a chip, there's a flash memory, so that's probably where the firmware is. That actually probably could be one of the main, looks like a video processor chip though. It's probably, yeah, that's the HDMI port internally for the HD-Base-T. There's the input board here. It's USB, probably for interface or control. There's a clock battery on the top, the chips we've seen before. There's actually a separate board for controlling the actual 3 LCD system here. There's 2 flex cables that connect and what looks like a little chip with a buffer on it. There's 3 LCDs, one for red, green, and blue. That board probably just splits it. We'll have a look under it. So under that board, we actually have another chip, and EMI shield actually pops off. Looks like it's got quite a lot of DRAM here, so that's probably doing some video processing with a buffer or something in those chips. That's an Epson chip, it looks like, on top. Doesn't look like there's any cooling or anything on it, interestingly. It's got a heat spreader, though. It's, under that board, we can get a closer look at the LCDs. You can see the liquid cooling running between them, little copper tubes and heatsink fins for the LCDs, I'm guessing. So now we can get a better look inside the machine without the boards in. There's the liquid cooling reservoir. It looks like it's double layer. It's got a cage around it. It's a tubing, and that goes back to the LCDs as we saw. There's a power supply section, I think. That's where the AC comes in. Lamp section, as we saw before. We got the ballast, that duct for air, and the optical engine. So after I filmed this video, I actually went ahead and labeled all the parts in here to the best of my ability. It looks like there's actually a peltier cooler in here. It's not only liquid cooled, it's actually chilled. And that's probably because the LCDs are getting really hot. And that's because for 8700 lumens of output, the optical engine is only about, I think I read about 12% efficient somewhere. So most of the light, so there's actually way more than 8700 lumens coming out of those lamps. And especially if the projector is displaying like a black screen or something, so much of that light is actually being dissipated and absorbed as heat by the LCD panels, and it'll cause them to heat up and get damaged. So they're actually chilling the coolant, probably not below ambient to prevent condensation, but they're definitely chilling it below what the air in the projector would probably be at, just to keep those LCDs cool and prevent them from burning up. As for the rest of the cooling design, it's pretty straightforward. There's probably a chassis airflow from somewhere. Probably after it's done cooling the LCDs, it comes out in the middle of the machine and goes through that lamp ballast fan and through the power supply fans. Pretty much everything discharges into the lamp compartment, so the lamps are probably the hottest parts in the whole system, so they're getting hot air, and there's exhaust fans that I've taken out already that suck all the hot air out after the lamps. So it's pretty much it's from one side to the back cooling overall in the system. Pretty much all the air goes to the exhaust fans and the intake fans, there's three. And that's actually pretty important that there's no air coming from outside or extra vents in the enclosure, because all the optics are being exposed to the cooling air, and you want all of that air to be filtered, because otherwise you're going to get dust and debris on the optics, and that's going to degrade the image over time. Actually, some air-cooled projectors, they do actually have that problem where the LCD and the optics build up dust over time, even though there's a filter. Moving on to the front of the projector, we have a power input board. It looks like a non-isolated power supply there with a little inductor and a little chip. There's a relay, a 3-volt relay, and probably that's to bypass that big resistor for inrush limiting, I think. There's an NTC and there's a bunch of low voltage circuits. If we take out the power supply module, you can actually see there's two power supplies strapped together, and you have the EMI input filters. Look like a bunch of common mode chokes and some capacitors. And there's blower fans, same one as the ones used in the lamp for the power supplies. And they're back to back, a little mesh in the back. So here's the power supplies. Looks like a big rectifier, and then there's a really big active PFC section, which is why this is a universal 100 to 240 volt unit. And they supply that DC bus through that connector right next to the capacitors, right to the lamp ballasts. So it's a high voltage DC ballast, and you can see most of the power supplies for the PFC, because the actual part that supplies the digital is actually pretty small. Behind that duct, we can see the heatsink for the Peltier coolers. That's the hot side, and there's a heat pipe in there too. So the next part that has to come out is the optical engine, so I thought I'd post a picture of that here for anyone who's interested in having a detailed look. And then I'll follow up with a labeled picture as usual. So the light starts out in both lamps, and they take a right angle turn, go through that shutter and the primary optics. There's bottom side cooling for all those optics right in front of the lamp. It goes to, hits that first mirror. It's I think it's a dichroic mirror, and it splits off the blue and the green and the red. So the red takes a couple right angle turns through some lenses, and goes right into the red LCD. And then the blue and the green get separated out with mirrors, and basically the green gets reflected off the second one, goes in the middle, and the blue just goes straight through that last mirror, and takes a right angle turn and right into the LCD. So it's splitting all that light, and then once it passes the polarizers and the LCD, light gets combined in a prism, and it shoots out the front as an image. And then the lens is separate, so I don't have that, so probably won't be able to have a look at that today. So if we shine a flashlight into the optical engine, you can see this color splitting in action. You can see the red, green, and blue channels getting separated out going through those lenses. And of course, there's quite a lot of light in there. It's not a very bright flashlight. I'm not sure how well that shows up on video, but let me try sticking the camera in there so you can probably see the red light being reflected off that mirror out down there. And that's just going through the lenses, and you can see the red light probably. And down here, you know, this is it's facing the red lens. That's probably still going to be all the reflected red light. And behind that, let's see if we can get the phone in. Behind that, we got the blue one. It's a blue light coming out of that lens, and that's basically how the light engine works. You can take out the flashlight. So I've got the cover off the heat sink for the LCD cooling system. So you got actually two peltier chips, or thermoelectric coolers, and basically one side gets really hot and one side gets really cold. So it's a semiconductor heat pump. In here it's attached to a pretty shiny heatsink. It's quite large. Interestingly, it doesn't cover the whole plate. Here's a shock-mounted pump. Kind of wiggles around. So they went to quite a lot of trouble to shock mount that pump. I would imagine a pump like this, it looks like a centrifugal pump, so it probably shouldn't vibrate that much, but I guess they wanted to be safe because optics. Here's the filter compartment coming off, and that's the two intake fans on the bottom, and there's the intake fan on the side. That's a NMB fan, 12 volts as usual. Down there, got two big blowers. Those are probably blowing underneath the LCDs to keep those cool, and probably the polarizers. In here we can get a closer look at the LCDs actually. We've got the front assembly out. You can see the frame around the LCDs. I'm not sure if the liquid touches the LCD itself. I'm probably not going to go there because it's a mess, but moving on to the front lens mount, you can see the really fine pitch lead screws that are in the ball slides. They actually look like drawer slides or server rails, but those allow the lens to move side to side and up and down, and that's your position adjustment you can get on the remote control. It's open loop control, no stepping motors here, but the pitch is quite fine, so pretty good precision. You got motor for X and Y. Down there you can see the lead screw for the X direction, the other one's for Y, I think. And I think that's a shutter in that box up there. So basically, here we have the light engine out of the projector. Underneath we can see all that underside cooling system. You know, it's all in that cast aluminum, I think, casing. It's got all the fans blowing in. Those are the ducts for the LCDs, and yeah, that's about it for the inside. I'll just quickly throw up a picture of that. Made some markings on it, as usual. So here's the lamp ballast. I've taken them out. There's not actually a lot of information about UHP lamp ballasts on the internet, other than they require high voltage to start, and I'm guessing they're probably constant current devices. So what it looks like is it looks like a big DC-DC converter, actually. That's what it really looks like, and two big transformers for the high voltage probably. Of course, I haven't actually traced out the boards or anything. I'll probably do that later, because I do have two of them. I'll probably try and figure out how they work. But meanwhile, what's left in the bottom here is mostly just large pieces of the enclosure and big castings, pretty heavy. Not that heavy. I think they're aluminum or something. They hold the thing together and form the base of the light engine. So there's not that much left to take apart now. It's pretty much done with this. This teardown actually took about 3 hours. I've edited it down to about 20 minutes or so. And there's parts everywhere in my room now. The liquid cooling system and the LCDs I'll keep for maybe a later video perhaps. We'll see. And yeah, it's all intact. There's probably like 100 things I didn't talk about in the video, so feel free to leave a comment and ask, and I'll try to reply to them, you know, if I get the time to. Yeah, thanks.